Thanks everyone for coming. My name is James. I work for UNICEF, and I work in the supply division of UNICEF based in Copenhagen. I'm here today to tell you about an experiment and a POC we did with Gurobi and Databricks to optimize what we do every day for a very life-saving cause in this case. Hope this works. Yeah, okay. So just, I won't go through the agenda, but I'll cover the main parts, and I'll be fast because I think we're running out of time. So I always start with this slide. Okay, this is a bit more of a technical audience I'm used to speaking to, so bear with me. You're all, this will look very familiar to you. So in the team that I work in, I manage a large portfolio of data engineers and application developers that build applications and data products for our supply chain. And we spend a lot of time here ingesting data, sorting it, cataloging it. We're on a data governance journey as well. And then we have an analyst team that can take those and build dashboards and products for our stakeholders and our partners and even our beneficiaries to kind of make sense of what we're doing. I think this sometimes gets missed, but I'm sure everyone sitting here has been here. So I think it's really important to kind of remind ourselves where we invest a lot of our time. So as I said, I work in this place. This is the largest humanitarian warehouse in the world. It's based in Copenhagen. We do stockpile some emergency supplies there. We always keep around 3 months, I think, on hand of our main kind of emergency items. So when crises happen around the world, earthquakes, situation in Palestine, etc., we are ready to go to ship things out of there. But we also do run all the procurement. So for nutrition, in this case, we work with over 20 vendors that create the product, and we raise the POs that ship from the countries that it's produced to the country that needs it. And we run that whole supply chain and help countries get what they need. So yeah, a couple of things that we do. We run the supply operation. We also shape the market. We influence markets as well to develop things that we need for the places that we work. And that's a big part of what we do, especially over the last 5 years. What we call product innovation to really help the market design and produce for us things that are very useful to our mandate. We're also a center of expertise for specifications, nutrition formulation, many things. This gives you an idea of the numbers. So we are quite a large operation, I would say. We're over 7 billion. Some of that is services, but a lot of it is goods. And, it's quite amazing when we discovered linear optimization, because it could have a huge impact on what we do. And as you can see, the numbers are increasing year on year. And it's getting worse as some of the events in the world are getting worse at the same time. So the nutrition, so for those of you who don't know what RUTF is, it stands for Ready to Eat Therapeutic Food. It's a bar, like an energy bar, that's very high in amino acids and other life-saving. If you're a severely malnutrition child, you could eat this. It's called plumpy nut as well. You can eat this bar to kind of bring up your levels to even be able to eat normal food again. And we ship a lot of it, and it's particularly over the last few years. We're in a current nutrition crisis, mainly around the Horn of Africa and in Asia, but it is growing exponentially year on year, and you'll see a chart on that in a minute. So it's a really life-saving product for us, and it's one of the main things that we tend to not store in the warehouse, but help the vendors ship it from the countries that need it. So we run the demand, we run the supply, and we put the two together and hopefully make the optimal allocation. So it's all about making the best allocation of those supplies to the countries that need it. So we are in the current phase of what we call wasting. So severe malnutrition in all the countries highlighted there. This is the percentage that it's growing. And this is the data from 2022. And you can see that it's trending drastically upwards. So for the last couple of years, we've gone from procuring what we would consider a steady state amount of IETF to a huge uptake in the demand due to the prevalence of wasting that's happening around the world. So it's incredibly important that we are as efficient as possible in procuring and allocating this key resource. And that has also had the result in that there are more suppliers, which is a good thing. More suppliers closer to where the demand is, which is also very key. And that has, kind of helped us ensure that we have enough supply available for those that need it. What it does mean is that we end up with something like this. So this is great having many suppliers and distributed geographically. That's a good thing for us, but we could also we get into a mess a little bit if we're not careful of, shipping supply from one country to another where it doesn't make sense. Now, usually the freight and the geographic rules and even the contractual rules would dictate good routes. But even with that, there's a lot that you could do that doesn't make sense if you were looking at it purely in an Excel spreadsheet and trying to, oh, that guy's got that much, let me ship it over there. The lead time, the days that it takes to get that product from that country to the country that produces, the country that utilizes it, could be weeks or months. And every day saved when doing this is potentially life-saving. So it's really important that we get this right, and which is why we've kind of looked to optimization as a key way of achieving that. So we undertook this year a proof of concept project with Databricks, who we work with, and Microsoft, who kind of made the connection happen. And then Gurobi came in. I have a good story on that later. To how could we use some tools and some techniques to improve our allocation decision-making capability. So met with Databricks. And so my team was telling me, yeah, we need AI, we need ChatGPT to fix this for us. And I was like, oh, I'm not sure, let's hear what Databricks have to say. And they were like, well, you have a classical OR problem, and probably what you need is mixed integer programming. So we conducted a POC with them around February. And yeah, this was some of the problems we were trying to solve. And at the same time we were doing this, we were implementing a data platform, which we didn't really have. Even to be able to work with their data scientists, we had to kind of, as they were working, run behind them to do the data engineering, get the data in place, and provide a place where we could work. So that was all happening at once. So we, again, in this room, this will be probably obvious, but we have a classical transportation problem. And they very clearly articulated as you need to utilize mixed integer programming for this. We need to define an objective function, some decision variables, and a set of constraints that we can then build you a model, and then you can test that model against your problem. So I find this slide super useful. I got it from the internet, but when I try and explain mixed integer programming to people, what does that mean? I mean, so essentially we're dealing with massive Cartesian products of suppliers, of places they need to go. There might be warehouses in the middle, but this set of scientific research solves this problem. And I was almost kicking myself when I discovered it. I was like, oh, why didn't we know about that before? But there you go. And it's so super happy that there is a good domain that ready to kind of solve these problems. So we need to see how much country needs per month. So we do that. We run that in an Excel on a SharePoint for now. We have plans to innovate that in the future, but we're the UN. You can imagine there's a lot of Excel going around. So we're collecting the rolling demand from each country per month. We also, from the suppliers, are collecting their capacity and availability monthly. So our main unit of time here is month. We're a big SAP organization, so we have from our SAP system the lead times for each country destination combination. So we can compute that every day, what the actuals are, so not the forecasted, the actual lead time it took from country A to country B expressed in days. So we're getting that. And then we have to take into account contractual agreements and also political sensitivities for certain country supply combinations. And that it's not written down anywhere sometimes. We have to go out and sit with the teams and understand what that is. And basically we put together a feasibility matrix that helps us understand who can ship to who. So two of the objective functions will to meet the country demands, optionally weight those to reflect priorities or UNICEF supply chain insights. So if we know that a big emergency has just happened, we can optimize, influence the optimization to upweight that country and move the demand there or move the supply there. And most importantly, minimize shipping time wherever possible to get that product to the country that needs it as quickly as possible. So we got a few decision variables. So we have the POs by supplier, by country, by month coming from our SAP system. We've got the shipments as well happening. So we know what's currently allocated, what is currently on the PO, and we know the actual lead times that are there. So we're working with as real data as we can get, and we're computing that every day. We need to make sure that any POs that we plan don't exceed supply availability, for that month, kind of obvious, but, it needs to be there. Country demands are met, and we have the option to meet funded country demands, meaning that country has the money to pay for the supplies, and also unfunded, because even if the country doesn't have the money yet, it's still a need that we have to plan for, because as we get closer to the time that they need it, usually funding is made available. So we have to plan for everything, not just what is currently funded. So we have the shipment lead time per country, and then the supply inventory per month, which we take into account previous entry plus new POs. Go to the next one. So input data. So to summarize, country demand forecast by month, supply availability by month, POs that are currently there, and the lead times. Putting that all together, it looks like this. Now, probably again, I don't have to tell this room that it was paramount that first column was as correct as we could get it. The input data, without having good data, and we spent a lot of time investing in there, in ETL and in pipelines and validation, because if we were pumping into this thing inaccurate data, the results were inaccurate, and therefore the nutrition team were like, well, this is great, but this doesn't make sense. I can't work with this. So we spend a lot of time there making sure that, and that's more classical data engineering, but again, we use Databricks to kind of help us with that and to set up a whole kind of end-to-end life cycle around this. We built a workflow where availability from suppliers could be validated through the specialists that work with them day to day. So we knew that they were accurate and they weren't kind of upweighting their volume to be preferred in any way. So we built a workflow for that. And then what this informs is procurement and shipment plans. It results in essentially what's called an allocation table, which is the main artifact that our teams use to raise POs and assign an amount of supply to a demand. So during the 6 months we were working on this, we have a web portal, and we built this screen into it, which was a way of like receiving and confirming what the suppliers were saying, because we were collecting that in emails and Excels. So we tried to innovate ourselves along the way, and for such an important input, we needed to put something like this together. And it also tracked like what they said previously versus what they were saying today. A little bit of the technology overview. I know it's important sometimes to cover that. So we have our data sources. It's our SAP ERP system. That's our POs, SOs, operational data, master data. We have a data warehouse, classical data warehouse, where we're compiling all of that. We have our online portal that we use to replace some of the manual processes that used to be there. So in parallel to implementing the solver, we were busy trying to implement some of the inputs. We bring all that together into Databricks, which is the platform that is also running Gurobi solver. So we work with Ronald to help us figure out how to run that and how to make it efficient. And then we've got like this kind of abstract box here, which says online allocation tool. So today we're using some dashboarding. Tomorrow, we think this is probably going to be integrated into our planning system, which is the project that we've got and coming out next year. It's still interesting to see how we would consume this data and what system will actually interact with this to get the results out. But it's got a lot of interesting ways to do that. All right, I'm going to jump over to a live demo. It's either a good idea or a bad idea, but we'll give it a go. So what this results in is this dashboard. So we run every day, we have a pipeline that ingests all the data inputs that I discussed, runs the model against a set of predefined scenarios, and allows our team to kind of make sense of what is the model telling them. So I noticed, I think in the LPT talk, there was an emphasis on like, how do you make this translatable to the business that needs to consume it? And this is one of the ways that we came up with. So on this dashboard, we pipe in the availability and the demand. So the red is everything not funded. The yellow is everything funded. So you can see like if we only consider funded demand, it's like not even half the story. It's incredibly important that we consider everything. You've got down here a list that in tabular format, all the country demands coming in, and you've got that mapped, and the heat map is here based on intensity of how many cartons like the standard box size for this product. And then we're able to spit out as well is what that looks like in a supply timeline. So I can even zoom in here, and you can see for each country how many cartons they receive and roughly when, based on what the model is producing from the input data. And then finally, a classic kind of allocation table that we could put together for the team to look through that and see, okay, which country is it, which vendor is the solver recommending, how many, when the country requested it. Oh, sorry. Oh, sorry. Oh, thank God you stopped me. I could have been. Oh, that's better. Okay. Let me just back up real quick. So I was saying supply demand coming in, demand from countries coming in, and the difference between unfunded and non-funded. The forecast demand in tabular format to just get an overview of who's demanding and what. Displayed on the map, so you can see the level of intensity of like how much compared to country size. And then this widget down here helps us see estimated how many cartons of a product would be going to which country and when. And then finally, a kind of classic allocation table, which shows which vendor, which going to which country, how many the quantity allocated, when they requested it, when the planned delivery date would be, and the lead time that was used in the solver to get to that output. And then we so estimate delivery time based on that, and then a bunch of other parameters that help us evaluate, did the solver do it early, did it do it later, and any of the kind of parameters that we use to get to that result. And then what's really cool about this, it just allows the team to step through some of because these are kind of pre-canned simulations, it allows the team to step through different scenarios. They can change some of the dials here. So change the sample, change the order tolerance, decide how many days early or late a shipment could be, and it will interactively change this timeline and this allocation result. So by using this, we're able to kind of quickly validate, is this producing something that you can actually use in production? Is it, if it's spitting out an allocation doesn't make sense, where? And we did find cases of that, and it was usually because, oh, we would never ship from that supply to that country because they don't talk to each other, or we don't have those contractual agreements in place, or whatever it may be. So few rounds of dialing in the process. Let me just go back to my deck here. I'm almost done. Yeah, so a couple of interesting facts. So technology I went through, a combination of supply and demand locations were over 65,000 distinct routes, not something you can do manually. So again, like absolutely needed. POC was around 80 hours of like code time, but a lot of weeks and months just getting the setup there internally and getting the whole thing together. For us, it was the first time we've embarked on something like this, so it was an amazing learning experience. This is my favorite fact. So we ran the model, first ran it, and it took 2 hours. So the Databricks guys called us up like, got some good news and bad news. Good news is we can run it, takes about 2 hours. So that was the bad news. But the good news is that you can dramatically speed that up. And there is a market of solvers, and I had no idea that existed. And they're Americans, so they said the Cadillac of the solvers is Gurobi. And there are others, but they're the best. And I was like, all right, let's not talk about the others. Let me call them up. Called up. I sent an email to the support email, I think. Chris got in touch. Ronald got in touch. And we got it down to less than a minute. And in fact, the wall clock time is 7 seconds. So pretty dramatic speed up by the time we'd re-engineered it in Gurobi Pi. So yeah, this is only one thing, one product and a product family actually, and we have over 10,000 products across many product groups where this could be applied. It's amazing that we are not utilizing this to the level we could. I like to say that the public sector sometimes 5 to 10 years behind private sector. In this case, it's probably true. But it's good that we found it now. So the next steps are to kind of, we're always refining the code. We're comparing like this pre-can strategy approach versus real time. We put the Gurobi solver behind an API. So we could actually call it and get results back. And if we're looking at a 7-second response time, it makes it more feasible to do like real time what if analysis. So we're looking into that. And then there are more business requirements like, okay, we solve for lead time. Can we solve for cost as well? So do multi-constraint. So that's something we're looking at. And also a lot of validation and testing and be used for other products. So yeah, thanks so much for having us. Thank you to Ronald and team for helping us. Go ahead.
Thank you. That was a great presentation. Thank you. How did you choose the bar product as the first out of the 10,000 or 20,000 or whatever that number was? Some enormous
it's a good
number.
Question. So we had the crisis. So that was the demand spiked for it so much so that it was natural that this had all kind of experience of doing it kind of goes out the window when the demand spiked that high within a year. So the team approached me. They're like, we really need help with this. We can't do this in Excel anymore. It's beyond what we can do. So that was one reason. Another reason is that it is like mainly vendor to country, so supply to country. So that made it easy. And it's also predominantly by sea because it's quite a chunky product and heavy. We don't air freight it. And so there were long lead times. And if you don't choose the right country or supplier that gets the right port, you can end up with months. So it was an obvious one to choose, very relevant at the time, and everyone understands what IE2F, especially in the humanitarian space. Plumpy nut is like a thing. It's on posters everywhere. So it was really easy to get behind it and then explain to donors this is what we're doing. So yeah, an easy one to choose. The next biggest one would be vaccines for sure. Yeah.
Hey, thanks a lot. I was wondering, how do you measure your performance in this case? Like, what is your KPI?
So lead time, like reduction of lead time. Right. So not only on the planning side, but also on getting the product from A to B. So if we can raising POs, if we see that item arrived from that vendor to that country, or from a different vendor to that country, and it's even a week or a few days less than it used to be, and we can measure that quite accurately, then that's a good success for us. Like we brought that down by hopefully weeks, but even a few days saved is quite big.
And on a more detailed level, do you then sometimes need to make a decision between one country needed more or another country needs it more?
Absolutely.
Like how do you make this kind of?
So we built in later iterations, we built in a way to kind of upweight by exclusion, basically, of like removing some countries from the demand to prioritize others. So we could just allocate to a smaller subset of countries that we know needed it more. And there is still a human in the loop with this. So the allocation results are taken and they're acted on as is or with some adjustments. So, but yeah, that whole concept of weighting in a linear programming context was an interesting one. We talked about a bit like how to do it. We've come up with this so far, but I think we will further iterate that, because it's sometimes in emergencies, we need to say, all right, just scrap the plan. These are your countries. And even on the supplier side, these are your suppliers. Allocate just from these subsets of the total demand and the total supply. Yeah.
Thanks.
No problem. Okay, thank you.